Now, let us discuss the second mode of propagation, that is, second mode of propagation, that is, ionospheric or space wave propagation. So, in the introduction to wave propagation, what we have studied regarding ionospheric or sky wave propagation. So, we have studied that any frequency signal in between 2 megahertz to 30 megahertz signal I can transmit by using ionospheric wave or space wave propagation. It is also called as point-to-point communication. Okay, so what is the height in the how much height above the Earth surface it will take? It takes from 50 kilometers to 400 kilometers. Okay, so coming to the diagram, this is my Earth surface. If this is my Earth surface, this is my ionosphere. Let us consider this is my ionosphere. So this region is my ionosphere. It extends from 50 kilometers to, this is 50 kilometers. It extends to 50 kilometers to 400 kilometers. Okay. So let us consider this is my transmitting antenna and this is my receiving antenna. This is transmitting antenna and receiving antenna. Okay, so any signal that enters into the ionosphere, reflect back and bend back and come to the receiver, and bend back and come to the receiver. So this is how we will in the previous coming classes we will study how the wave will get bent back in the ionosphere and comes to the Earth surface. So which type of signals it will bend back? Those frequency signals less than 2 megahertz, 30 megahertz. 30 megahertz. Okay, so before this is nothing but from here to here, this is nothing but ionosphere layer. Ionosphere layer. Okay, now let us first study what is the structure of ionosphere. Structure of ionosphere. What are the things? How many? What are the layers present in ionosphere? Very important one. Okay, so the upper part of the atmosphere, the upper part of the atmosphere. Okay, study structure of ionosphere. Structure of ionosphere. Okay, structure of ionosphere or space wave propagation. Structure of ionosphere or space wave propagation. So the upper part of the atmosphere, the upper part of the atmosphere, upper part of the atmosphere, where the ionization is appreciable. Appreciable is known as ionosphere. Is known as ionosphere. We know that what is meant by ionization? Ionization means either gaining an electron or losing an electron. Okay, so that is nothing but the ionization, losing or gaining. Okay, so that is called as ionization. So the upper part of the atmosphere where the ionization is appreciable is known as ionosphere. Okay, so let us see here coming to the structure of ionosphere. Let us see here. This is the structure of ionosphere. Drawing the diagram. Okay, so drawing the diagram. Let us consider this is my Earth surface. This is my Earth surface. This is my Earth surface. Okay, so let us consider. Okay, so initially here troposphere layer will be there. After that, let us consider troposphere is extended up to 16 kilometers. Beyond that, let us consider this is 50 kilometers where the ionosphere starts. Structure of ionosphere. Okay. Study structure of sphere. Okay. So coming to the structure of ionosphere. Okay. The first layer of ionosphere, it is D layer. The first layer of ionosphere, it is D layer. So D layer extends from 50 kilometers to 90 kilometers. Okay. Next, coming to the second layer of the ionosphere, it is E layer. So E layer extends from 90 kilometers to 140 kilometers. E layer extends from 90 kilometers to 140 kilometers. Okay. So after E layer, we are having the F1 layer. F1 layer extends from 140 kilometers to 250 kilometers. F1 layer extends from 140 to 250 kilometers. And so the next layer of ionosphere is F2 layer. Is F2 layer. F2 layer extends from 250 kilometers to 400 kilometers. Okay. So this is outer atmosphere region. This is outer atmosphere region. Okay. At outer atmosphere region. Okay. So this is the brief structure of ionosphere. So total how many layers are there in ionosphere? So D layer. D layer extends from 50 to 90 kilometers. Next one is E layer. E layer extends from 90 to 140 kilometers. The F1 layer. F1 layer extends from 140 to 250 kilometers. The F2 layer. The F2 layer extends from 250 to 400. Okay. So in this, so since this all we get, this is the brief structure. So totally, how many layers are there? D layer, E layer, F1 layer, F2 layer, D layer, E layer, F1 layer, F2 layer. Okay. So D layer is from 50 kilometers to 90 kilometers. E layer is from 90 to 140 kilometers. F1 layer is from 140 to 250 kilometers. F2 is from 250 kilometers to 400 kilometers. Okay. So among these all regions, which region consists of more electrons? Which region consists of more electron hole pairs? Okay. So let us see here. Here, this is the above Earth surface. Let us consider this is our sun. Okay. This is our sun. Now tell me which region will receive more heat from the Earth surface, from the sun? No doubt, F2 region will receive more heat or radiation from the Earth surface. So here in F2, for example, if the charges are there, okay, so due to this more heat, okay, the collision, the rupture of bonds, ionic bonds will take place, and more number of free electrons will be present in F2 layer. More number of free electrons, more number of free electrons are present in F2 layer. Why? Because the F2 layer is very nearer to the Earth surface. It is very nearer to the Earth surface. Okay, so since it is very nearer to the Earth surface, collision takes place. So due to that heat, more number of bonds will break that leads to the free electron. So when compared to F2 layer, which which layer will occupy more electrons? That is nothing but F1. Among this very important thing, among these four layers, which layer is heavily dense layer and which layer is lightly dense layer, or which layer consists of less number of electron hole pairs and which layer consists of more electron pairs? F2 layer, no doubt, since it is very nearer to the Earth surface, consists of more electron pairs. More electron pairs. Similarly, the D is very far away from the Earth surface, less number of collisions takes place, less number of ruptures will take place. Here I may get very less number of electrons. Okay. So in E, I will have more number of electrons when compared to D, because it is a little bit more far away from, far nearer to the sun. And compared to E, F1 is heavily densed. F1 is heavily densed. Electron hole pairs will be more. Okay. So if I draw the electron hole pair diagram, if I draw the electron hole pair versus electron density versus electron density versus height above the earth surface, height above the earth surface in daytime, in daytime, in daytime, height above the earth surface. So this is height above the earth surface, height. Okay, I'll try in the next slide. Okay, so the other special feature of this ionosphere is, for example, so see here, will this radiation, for example, let us take here, will the sun radiation will be always constant in the entire day? No. Afternoon, the sun radiation is high. When take night place, okay, the radiation is very, very less, or we don't even see the sun at night time. So in that, the radiation is less. So coming to the structure of ionosphere, morning or in the daytime, totally 4 layers will be available. What are the 4 layers? D layer, E layer, F1 layer, and F2 layer. But coming to the night time, the D layer will disappear. The D layer will disappear, and F1 and F2 layer will merge as F layer. So now tell me how many layers are present in the morning time? 4 layers. What are they? D layer, E layer, F1 layer, F2 layer. But at night time, D layer vanishes. D layer vanishes, and F1 and F2 layer combine as F layer. F1 and F2 layer combine as F layer. Okay, so this is very, very important. Which layer vanishes during night time? D layer. Which layer vanishes during night time? D layer. And how many layers will be there in night time? 2 layers. That is E layer and F layer. F1 and F2 will combinedly act as F layer. F1 and F2 will combinedly act as F layer. Okay, now, so I'm going to draw the electron density graph. Electron density graph. Okay, so during daytime. So totally during daytime, how many layers will be there? 4 layers. Nighttime, how many layers will be there? Why? Because the sun continuously doesn't supply the same voltage, same radiation for us. Okay, in the afternoon we'll get more suffocation. In night we feel a little bit cool. Okay, so because since this earth is rotating around the sun, whatever the temperature that is provided by the sun is not constant for the ionosphere. It changes in a day. Okay, so no doubt in the day, total how many layers are there? 4 layers will be there. 4 layers will be there. So on the y-axis, I am writing height above at the surface, height above at the surface, height above at the surface. On the x-axis, I am writing electron density. Electron density. Electron density is represented with N. N indicates number of electrons per cubic meter. What is this N? N indicates number of electrons per. N indicates number of electrons per cubic meter. Okay, so here if we take any small one cubic meter, how many number of electrons are there? That denotes N. Okay, N indicates number of electrons per cubic meter. Okay, so here our ionosphere layer starts from 50 kilometers. Okay, so this is 50 kilometers. So like this. Okay, so this is my D layer where the electron density is less. This is my E layer. This is my F1 layer. This is my F2 layer where I have more electron density. Where I have more electron density. Where I have more electron density. So F2 D layer is from 50 kilometers. E layer is up to 90. This is 140. This is up to 250. This is up to 400. So F1 layer, F2 layer consists of more electron density. Electron density. So if you write the definition, so electron density in F2 is greater than F1 is greater than E is greater than D. This is in during daytime. Now let us come to the night. Okay, I have already told that due to rotation of the earth. Okay, so initial morning time, in daytime, the ionosphere consists of 4 layers, but in night time only will have 2 layers. So draw the diagram. So on the x-axis, we are having electron density. On the x-axis, we are having electron density. On the y-axis is height above the surface. Height above at the surface. Height above at the surface. So here, what are the layers will be present here? In during night time. During night time, I will have only E layer and F layer. So E layer starts from 140 kilometers. So E layer starts from 140 kilometers. So this is my E layer and this is my F layer. And this is my F layer. So more number of electrons will be present in F layer. Okay, when compared to, so electron density. Okay, so the number of free electrons present in F layer is more when compared to the number of electrons present in E layer, that is during night time. It is during night time. So this is very, very important graph which gives the information regarding electron density or the number of electrons per cubic meter present in ionosphere during daytime and night time. So no doubt in daytime, so F2 layer will have more electron density when compared to F1 and when compared to E and D. Okay, so these are the electron density. Okay, now let us study one by one. So let us study the first layer, that is D layer. Okay, now let us study the first layer, that is D layer. Okay, so D region is the lowest region on the ionosphere. So D region, or so what are the 4 regions? The first one is D region. So what is the height? Height is from 50 to 90 kilometers. 50 kilometers to 90 kilometers. What about the electron density? The electron density in D layer is very, very less. Is very, very less. Electron density in D region is very, very less. And this is the lowermost region of the ionosphere. And it is the lowermost region of the ionosphere, and the electron density is also very, very less. Okay. So this layer is present only during, very, very important thing you want to remember, D region or D layer presents only during presents only during daytime. Only during daytime. Okay. So during night time it vanishes. During night time it vanishes. It vanishes. Okay. So the ionization density, however, it is maximum at noon. Okay. So the electron density in D region is maximum at noon, and the electron density is ranging from 10 power 14 to 10 power 16. 10 power 14 to 10 power 16 per cubic centimeter. Per cubic centimeter. Okay, so this is the brief introduction regarding D region. Okay, now let us come to the E region. So what is the height of the E region? E region height is from 90 kilometers to 140 kilometers. 90 kilometers to 140 kilometers. So the range of the E region is 90 kilometers. This is above the D region and below the F1 region. It is above the D region and below the F1 region. Okay. So this region normally is a narrow layer of ionization just above the D region, extending from 90 kilometers to 140 kilometers. Okay. So two scientists, namely A.E. Kenley in USA and the other one, Oliver Heaviside. Oliver H-E-A-V-A Heaviside. Okay. They two independently predicted that there is an E layer. So hence, from this two scientists' name, E layer is also called as Kenley Heaviside. E layer, E region or is also called as Kenley Heaviside region. So E region is also called as Kenley Heaviside region. Okay, so coming to the electron density, it ranges from 10 power 5 to 4.5 into 10 to the power of 5 during daytime and 5 into 10 to the power of 3 to 10 to the power of 4 at night time. Okay, so this is maximum at um, uh, afternoon time because okay, so critical frequency of E layer is up to 3 megahertz to 5 megahertz. Okay, so E region, what is the other name of the E region? It is also called as Kenley Heaviside region. Kenley Heaviside region. Okay, now let us discuss with the F1 layer. F1 layer. What is the height of the F1 layer? It extends from 140 kilometers to 250 kilometers. 140 kilometers to 250 kilometers. Okay, so similarly, F2 layer. So this is the uppermost layer. It extends from 250 kilometers to 400 kilometers. Okay, so during night time, F1 and F2 during night time, F1 and F2 get merge and form as F layer. Okay, so the other name of F layer, the other name of F layer is Appleton. The other name of F region. The other name of F region is Appleton region. Appleton region. The Appleton region. Okay, so this is very highly dense region. Okay, so F2 layer is heavily dense region. Okay, so these are all the brief introduction and structure of ionosphere. Okay, structure of ionosphere. So totally we are having 4 layers. So that 4 layers in a ionosphere or space propagation: D layer, E layer, F1 layer, F2 layer.